we're now going to look more at the atomic nucleus and how nuclear physics works. So we talked about atomic physics, talking about how atoms are constructed and how electrons can exist in different specified orbits, and how when an electron moves in an orbit, it does so by absorbing or emitting a photon. But now we're going to focus more on the internal workings of the nucleus itself. So it was accidentally discovered that some materials actually radiate invisible penetrating particles. For example, if you hold a rock that contains uranium in it, that rock might feel warm to you. And it was one of those odd things back, when nuclear physics was first starting, that you would have a radioactive substance and you would note that, hey, it feels warm. In fact, that's what currently heats the Earth. The fact that the core of the Earth is this big molten solid iron core with a liquid iron surrounding it, the hot rock mantle in the Earth is heated by radioactive decay. So taking one of these radioactive rocks, these rocks that feel oddly warm, and placing it near photographic film, when that film is later developed, surprisingly, it has the marks on it from the radiation given off by these radioactive rocks. And looking more deeply at the type of radiation given off, physicists realize there are three different types of nuclear radiation. There's alpha particles, or alpha radiation, shown by the Greek letter alpha. These, we'll talk in more detail about what these are, but alpha radiation, these are massive particles. They're strongly charged. They have a charge of plus 2e. Remember, E is the fundamental charge, 6.02 times 10 to the minus 19 coulombs. And they're weakly penetrating. They would have trouble getting through a piece of paper. The next we have beta particles. Again, the Greek letter beta. These are lower mass, not nearly as massive as alpha particles, about 8,000 times less massive. They are charged like alpha particles are, but not quite as much, and they can have positive or negative charge of 1e. So they can have the same charge as an electron or the exact opposite charge of plus e. And they're moderately penetrating. They can easily make it through a sheet of paper, but making it through a few inches of lead certainly can't do that. And then finally, gamma particles. Gamma particles have no mass. They have no charge, and they are strongly penetrating. They can easily make it through paper and moderate thicknesses of most materials. So what creates alpha, beta, and gamma particles? That's what we'll be investigating in this